I have a golf ball, and I'm launching it at an angle of 28 degrees. So I am going to grab my arrows. I'm going to draw this out. So this would represent the initial velocity, the starting velocity. I'm going to launch that golf ball. And after it's launched, it's going to go up, 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 and then it'll start coming back down. All right. And when it comes back down, it is going to land at 28 degrees. So if this angle is 28 degrees, then this angle is going to be 28 degrees. And whatever this velocity was that it was launched at, that's going to be the velocity that it hits the ground at. All right. We know a few other things. So we always know that the velocity in the y direction at that highest point that it reaches, that's always going to be 0. So remember, as it goes up, it loses velocity in the y direction until in the y direction it basically hangs in the air for one moment, and then it falls back down. And it picks up speed, and it loses speed at a rate of 9.8 meters per second per second. It gains speed at a rate of 9.8 meters per second per second. Now we also know the time from the beginning all the way to the end is 4.7 seconds. Okay, so the entire time would be 4.7 seconds. That means that if I were to treat this like a cliff problem, if I were to pretend that it was launched horizontally off of a cliff, right, that the time it would take for half of the travel would be 2.35 seconds. Okay, so that's the time for half of the travel. And if we treat it like a cliff problem, then we know the original velocity in the y, that it will be 0. And we also know that the velocity at the end is going to have an angle of 28 degrees. Now that's important because we're going to have to use it. We're going to have to use some trig. Now we know the time in air. What we could do is we could figure out the height from that. So we could figure out how tall or how high it got. And remember, the equation for dy is VOYT plus 1/2 GT squared. So right now what we're doing is we're finding maximum height. All right. So dy is going to equal 0 times 2.35. You know that'll just be 0. Plus 1/2 times 9.8 times 2.35 squared. And I plug that in my calculator, and I would get
27.1.
Sounds right. My guess and check was going to be 26. So 27.1 meters. So it got 27.1 meters above the ground. So when it went up, 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 at that highest point, 27 meters high. Now I'm going to clone this page. Okay, because I'm running out of space. So now we know dy is 27. I'm going to erase that just to try to get myself some space. I'll rewrite that time. So we know that the time for half of the trip, we said that was 2.35 seconds. We also know that dy now, we said 27.1 meters. So the next thing I want to find is, let's find the final velocity. Okay? So I need to find VF. Well, in order to find VF, you guys, I'm going to find VFY before that. And here's why. because I know that VF is going to form a triangle where I'll have a component that's in the x direction and one that's in the y direction. So we'll have VFY and we'll have VX. And it would be nice if I could make that a 90-degree angle. There we go. Much better. So, so this would be VF, the hypotenuse. This is going to be VFY. This is going to be Vx. And I know this is 28. So because you know trig, because you know your trig functions, you know that if I know one angle and one side, I could figure out the other sides. So VFY, that's the easiest side to find. And it's the easiest side to find because I don't even have to do algebra. We have an equation that says VFY is the original velocity in the y direction plus gravity times time. So this would be 0. This would be 9.8. And remember, we're going to use that half time here because anything in the y, we're going to use the half time. So that'll be 2.35. And 9.8 times 2.35 is going to be what? I'm going to say real close to 23.
Yeah, it's 23.
23.
Well, I mean, it's 23.04, but I was putting
Okay.
20.
Yep, we're fine with that. So 23 meters per second. So that's my final velocity in the y direction. So now I know this side of the triangle. If I know this side of the triangle, I could figure out all sides because I know that angle. Okay? So this side is the opposite side from 28. If I want to figure out the hypotenuse, what trig function is opposite over hypotenuse? Sine, that's right. So the sine, we'll use the sine of the angle, right, is opposite over hypotenuse. That's the SO in SOHCAHTOA. So in my calculator, I would have sine of 28 equals, the opposite side is 23, divided by the hypotenuse. Now, if I do algebra here, right, the easiest way to solve for a variable that's on the bottom, you guys, what I would do, because you're good at it, I would cross multiply. I would pretend this is a fraction. So the sine of 28 divided by 1, that makes it a fraction. And then I would just cross multiply here. So what I end up with is the hypotenuse times the sine of 28 equals 23. Now how would I get rid of the sine of 28? You would just do what to both sides? Divide. So I'll divide both sides by the sine of 28. Those will disappear, and I'll end up with the hypotenuse is equal to 23 divided by the sine of 28. Can someone tell me what that is? I'll get out my calculator too.
$49.
Oh, okay.
If you round to like the whole number.
Okay, that's fine. 49 you said?
Yeah.
Okay. So that is 49 meters per second. That's just going to be our units. So this is 49 meters per second. That was 23 meters per second.
Mr. Boatman, can you let Sebastian in the call?
Oh yeah, he got kicked out, huh?
Yeah.
Thank you for letting me know. There we go. So right now, if I wanted to know the final velocity, well, the final velocity is 49 meters per second at 28 degrees. So that's how hard it's hitting the ground. Is everybody still with me? Yeah? Okay, got a thumbs up. So I'm going to clone this page again. I'm running out of space again. And I'm going to delete some of this again. I'm going to delete this part out. Okay, we already know VFY now is 23. We know that this is the actual final velocity. Okay, and I'm going to get rid of this. Okay. So now you guys, we have to solve for Vx, because what it's asking us, the final thing that it's asking us for is the range. The range is dx, and remember we have one equation in the x direction. It's Vx equals dx divided by time. So that's the only one we have. So I don't know Vx, I do know time, and remember in the x direction we have to use the whole time. So in the x direction we're going to use 4.7, but I don't know Vx. I can solve it from this triangle. I could either use trig, because this is the adjacent side, so I could use the tangent, I could use cosine, or I could use the Pythagorean theorem. Which would you guys prefer? Whoever shouts it out first.
Pythagorean theorem.
Pythagorean theorem. Okay. So Pythagorean theorem, a squared plus b squared equals c squared. So I'll have 23 squared plus the b squared, that'll be Vx, equals c squared, that would be 49 squared. So these are being added to each other. I would want to subtract out the 23 squared to both sides. So in my calculator, I would do 49 squared minus 23 squared. I don't know what that is.
It's 1,872, but square root that and you get 23.3.
Thank you. And everybody knows why Selma square rooted it. It's because this square has to go away. So I got to do the opposite square root. So
43.3, not 23.3.
oh, sorry. Thank you. I'll fix that. Okay, so this will be 43.3. That makes sense because this angle is pretty shallow. Once again, I did not draw it to scale. So Vx is 43.3 meters per second. Well, now I can solve for this because I know Vx is 43. I'm trying to find dx. And for the time, I have to use the whole time, not just the half time. So in the y direction, we always use this half of the time because we're pretending it's a cliff problem. In the x direction, I have to do the whole path of the ball from beginning to end. So this will be 4.7 seconds. Right now, the 4.7 is being divided. So to get rid of it, you would have to do the opposite, which is multiply it. So 43 times 4.7. Can someone tell me what that is?
202.1.
202.1 meters. So that's how far away the ball will land. That is the range, or the dx. So once again, lots of steps in these problems, right? There's lots of steps. There's lots of your old math that I know you knew was useful, and now you get to use it again. Is there another one that you want to do, or would you rather just go to the concept builders, you guys? It's up to you. I'll let you guys choose.
Can we do 5?
Yeah, of course. So problem 5. Okay. I have a soccer player, and they're making a shot on goal from 25 yards out. So the very first thing let's do before we get too far, we need to convert 25 yards. All right. So remember, if we do factor label, I have yards on top. I have to multiply this by some conversion factor where yards are on the bottom, meters are on the top, and I look at my, the yards will cancel. I look at my conversion sheet, and I'm pulling it up right now. And I look to see how many yards are in 1 meter. And on my conversion sheet, it says that there is 1.1 yards in 1 meter. So the yards here will cancel. 25 times 1 divided by 1.1. Can someone tell me what that is? I got 27.5. Did everyone else get the same thing?
What did you divide?
Oh no, I multiplied instead of dividing.
What were you dividing? 25 over 1.1?
Yep.
I got 20. If you round to like the whole number, I got 23.
Okay. What was it to the 10th place?
22.7.
Let's do 22.7. It'll make me feel better. All right, 22.7 meters. So basically, you guys, this is the problem setup. We're shooting. The ball's going to go up. It's going to come down. He's shooting 25 yards out, which we said is 22.7 meters away. That's going to be my DX. It says the ball grazes the top of the crossbar, which is 8 feet above the ground. So we got to convert that too. So let's do our factor label again. I have 8 feet. And I want to get rid of the feet and replace it with meters so that my answer will be in meters. And I have to look at my conversion sheet. I'm pulling it up again. And there's 2 different conversions on there, okay? But I'm going to use that 1 meter is 3.28 feet. So I would take 8 times 1 divided by 3.28. Feet will cancel. And that will equal 2 point what meters?
2.4 or 2.44.
Yeah, we'll round to the tenths, so we'll do 2.4. So this dy, you guys, that is going to be 2.4 meters. So dx, right, is the range that's along the ground. And then dy, that's how high it got. Okay, I'm going to delete my conversions. Is that okay with you guys? All right. Because I need room. And on the test, on these tests, you guys, I probably won't make you convert because there's just not enough time, right? But hopefully everybody knows how to do that. Okay, so what do I need to find out? It says calculate the velocity and launch angle of the ball as it leaves his foot. So I want to know the launch angle when it leaves his foot. And just so you guys know, remember the launch angle and the speed that it gets kicked at, that's going to be the exact same as the launch angle and the speed that it hits the ground at. So basically for us, we're going to label this as VF. We want to find VF. And then, yep, that's it. That's the only thing we need to find. All right. So remember that VF, when it hits the ground, so when that ball hits the ground, okay, it's going to be made up of some component of velocity in the x direction, and then it'll be some component of velocity in the y direction. So when I'm looking for VF, I have the x component and I have the y component. I add those 2 vectors, I get the resultant. And this angle right there, That'll be the launch angle because that's the same angle that it'll hit the ground at. So basically, in order to find VF, I need to find VX and VFY. Okay? Now, the first thing that we'll end up doing here, we know the height, but we don't have the time in air. Let's find the time in air. Okay? So we have this equation that dy equals VOY t plus 1/2 gt squared. Now we know that dy is 2.4. We're going to pretend, remember for this part in the y direction, we're going to pretend it's a cliff problem. So we're going to pretend it started at this highest point right there. At that highest point, velocity in the y direction was 0. 0 times anything will end up being 0. That'll be 1/2 times 9.8 times t squared. Okay, so if I just do my arithmetic, I'll get 2.4 equals 4.9 t squared. I got to get rid of this 4.9. So remember, I'll divide both sides by that. And after someone calculates that, they could tell me what it is.
I got 0.49.
Wait, so t squared equals 0.49? That seems reasonable, right? It's almost half. And then I want to get rid of the squared, so I need to take the square root. So what's the square root of 0.49?
0.7.
0.7. So remember that this is half of the time because we pretended it was a cliff problem here while it was moving across the ground. So the time for half of the trip from the top to the bottom is 0.7. That means the time for the whole trip is going to be 1.4. So if half of the time is 0.7, the time for the whole trip is going to be 1.4. In the y direction, we're always going to use this half time. In the x direction, we'll always use the whole time. Okay? Okay, so now we know time in air. Well, with time in air, I could find VFY and I can find VX. VFY, I can do without using any algebra because I know VFY is VOY plus gravity times time. And remember, because this is a ground-to-ground problem, we're going to use the half of the time. So the final velocity in the y is going to be 0 plus 9.8 times that half of the time, which will be 0.7. And 9.8 times 0.7, it's going to be 6 point something.
6.9.
6.9. So up in my triangle up here, this side of the triangle, 6.9 meters per second. Okay, now for Vx, also not going to have to use algebra because we have one equation, that's Vx equals dx over time. Well, I know dx, it's 22.7. And I know time, and remember I have to use the whole time, not just the half of the time, because I'm doing the up and the down. So the whole time is 1.4 seconds. So 22.7 divided by 1.4.
16.2.
16.2 meters per second. So that is going to be this side. So once again, you guys, I'm going to clone this because I am running out of space again. And let's, I am going to delete, oops, that was a mistake. I'm going to delete this side. Why won't it let me delete? Okay. All right. So now I have this triangle. I have to find this side of the triangle, and I have to find that angle. So you guys like using the Pythagorean theorem to find the side. Let's do that. I have 16.2 squared plus 6.9 squared equals c squared. So I would punch these two things in my calculator and add them. I'm sure someone's going to beat me to it.
Do you want the answer before square rooted or after?
Sure, why don't you give it to me before you square root it?
So before it's 310.05 or like 0.1.
Yeah, okay. And then after I square root it?
17.6.
17.6. So the final velocity, the final speed, I should say, is going to be 17.6 meters per second. The only part I'm missing now, so that it can be velocity, is the angle. We could use any trig function. We keep using tangent, so let's just do that again. If I want to find the angle, if I do the inverse tan of the opposite side over the adjacent side, so that would be 6.9 over 16.2. That'll give me the angle. I got it to be 23.1. Did everybody else get the same answer?
Yeah.
Okay. So then our final velocity is going to be 17.6 meters per second at 23.1 degrees. So that's the launch angle is 23.1. The speed off his foot, 17.6.